Hello, everyone. Welcome back. I hope you had a beautiful, short little break. We have our next speaker with us, Stuart Clark, and he's going to talk about the digital transformation through GitOps and the infrastructure as code. Stuart, the stage is yours.
Thank you so much. Let me just share my screen, make sure that I'm sharing there. Fantastic, I am. And thank you for the kind introduction. My name is Stuart Clark. I'm a technical leader and developer advocate with Cisco. You can follow me on Twitter at Big Evil Beard. Happy for any tweets or photo shots to be taken while we're going through this slide, or any questions you have to follow up. So let's jump into this. Let's jump into this session. So just a little bit about me before we start. I started my career as a hairdresser in 1990, which is a bit of a change. And for some people who see my beard at 2 foot long, think that's a bit of a peculiar thing to have. I changed my career at around the age of about 34. Wanted a new challenge, a new change, and so started in network engineering, and then worked my way into senior network engineering. And then, sort of around 7 years ago, I started to learn a lot more automation, became passionate about automation within network engineering. And then 5 years ago, became a developer advocate for network automation here at Cisco on the developer relations team. So, why network programmability? Why the shift into network programmability? A lot of teams and a lot of companies have taken this, and it's not just the big sort of big companies who have done this. In the last number of years, we've seen a tremendous shift from all levels, from both service provider and also enterprise, into network programmability. But why did everybody all of a sudden just do this change and stop doing something the way that we've been doing something for so many years and take up this new method? I like to use this camera as an example for this. So the camera that you see on the left-hand side is considered a traditional camera, which takes film. And then the one on the right-hand side is a modern camera, which takes a flash card. So when you use the camera on the left, let's say, for instance, you go on holiday, you go on vacation, or you go away somewhere special, and you take photos with the camera on the left-hand side. You can see that this particular film would take 36 pictures. So you take your pictures, and then you often come back from your trip, from your vacation, and you have to have the film developed. And normally you would send this off, or you would take it into a store and they'd develop the photographs for you. This is when you would see the results of your photographs. Now, often more than not, that you'd be disappointed with some of these photographs. The light might not have been right. There might have been something in the background. The photo might be blurry. The angle might be off. People might have their eyes closed. All of the things you kind of see when you see funny photos, I guess. And the photos don't come out, but you don't see that until you've had these developed. And often this can be a number of days, if not weeks, up until you've had that trip or that vacation. So this is where the camera on the right-hand side is in many ways superior, because as we know, with a modern camera, you can take the picture and then there's a little, viewfinder. I'm looking at one now. I use a mirrorless camera um, to provide my video streaming for this. Now I can see in the little screen the actual, the image that was taken. I also have the ability to adjust that image as well, add filters, and to adjust the light setting and all of the different options in there. So, what is the benefit that I'm getting at here? Well, the benefit is that the camera on the right shows you everything in a lot more real time. It gives you a lot more information within real time, and that's how I view network programmability and GitOps as a whole. Being able to see more detail in real time as it's happening, and being able to adjust and be a lot more agile when we are making changes or bringing up new services. So, what does this mean for engineers? Well, as I mentioned, I've been a network engineer for a number of years, and I've been through some of these various different ages, which we see on the screen, where we started out in the Stone Age, and then we moved into the Bronze Age. then into this kind of renaissance period. But it really started to kick off around the sort of 2020 era for a lot of companies, when we started talking about APIs and model-driven programmability using Python, Ansible, moving away into a hybrid cloud and having containers. And this is what we call in within network engineering, the blend of DevOps and network engineering is net DevOps. So this is the change that we've actually seen within this entire sort of lifespan of 30 years within network engineering. And this is what we did. And this is what we did for many, many years. The output that you'll see on my screen right now is a snippet taken from a router device, which is setting up a border gateway protocol, which, as we know, is the backbone, which is how the internet is all kind of glued together. But for any of you that know BGP or have worked with BGP, it's a very, very fragile protocol. One simple mistake can have catastrophic outcomes, such as a number of incidences, even at the big organizations like Amazon or even Facebook, when there was an outage recently where a misconfiguration in one of these lines happened, which caused an entire global infrastructure to go down for a number of hours, even lock people out of meeting rooms and lock people out of data centers, just for a simple thing. Now, often in real time, you can see how traffic is converged across a network, but sometimes it takes a period of time for reconvergence to happen, or for routes to be differently propagated, especially with BGP, and how things kind of change and how you see this shift in traffic. It's a very, very almost like how the weather changes, across your country or across the world. And this is what I was referring to when I mentioned that camera piece at the start. You can often make a change like this, and it can sometimes take a little bit of time for that change to be acknowledged or to be accepted. And in the case of changing something manually like this, you often see that change very, very gradually. There's nothing to have any sort of pre-checks by doing this manually on a device. So these are a lot of the shortcomings that we have for doing things in this kind of manual fashion by typing these commands out, or even copy and pasting these in, or even using a kind of expect script or automation to push these commands into all of our devices. The change is often instantaneous and there's no actual checking being done. So catastrophic outcomes can be quite often seen. So how do we move up from that? I mentioned pushing things out in automation and pushing things out in in different structures, but we can also do this within a code format. Automation of the CLI is very, very difficult to do. The CLI that I showed you before isn't meant for machine readability. It's meant for human construction or human readability. Behind the scenes of what you saw on that last screen is actually thousands of lines of code. If you take a root device or a switch device, you'll find that there's often 3,000 lines of code behind there. Most of the routers that we use today in production are actually Linux running in the background, or FreeBSD running in the background. So the router has the ability to understand a machine programmable language. So why not use one of those machine programmable languages? Well, one of the advantages of using the machine-based languages, this makes it a lot more simpler to store as well. It makes it also easier for other teams to read. The CLI being mentioned for human eyes is sometimes difficult to read, especially for teams who aren't familiar with that particular either vendor or that particular that CLI. Often, even network engineers have to learn, 3, 4, maybe even 5 different CLI commands across a thing to implement something which is actually a baseline standard, like BGP, which is actually standardized by RFCs and the IETF, for example. So moving them into machine readable code is really the beginning of our journey of infrastructure as code for a network engineer. And this is the first stepping stone within a team that I'm working with on how to transform their culture into a GitOps methodology. So you see on the left-hand side, we have YAML, and then we have JSON, we have XML. One of the questions you often get asked is when you're moving in, well, which is the best language? But sometimes this comes down to what the device will support or what the API will support, or sometimes it just comes down to personal preference. Personally, I'm a big fan of YAML and a big fan of JSON, and I do find XML just that little bit scary. But it's because within the environments that I work in, more preferred is YAML and JSON. So the first step is taking all of those CLI commands and actually turning them into machine readable languages. And we'll see why in just a second. But before we do that, and before we start working on this, often we have to sell this to the business. And this is one of the biggest challenges that I find is that as engineers are incredibly talented. Engineers like a challenge, very much like a big puzzle or a big crossword, for example. But we have to sell this to the business. We can build all of this great stuff. We can engineer all of these great resources, but we have to get our business to buy into this. And these are some of the points that when we go across to our business for wanting to do this change into this methodology that we have to speak of. One of the things we have to talk about is the disadvantages of manual operations and how much time that is actually costing our company and what is costing our company as well within mistakes. And this comes into the amount of hours and SLA breaches that you meet with your customers. The other point is the financial costs as well. And financial costs do come in the fact of how much we're paying in say, SLA credits to our customers, but also how many engineers we're actually putting into building and maintaining all of our infrastructure. It's very, very unlikely within many companies that as your infrastructure goes, you get additional headcount. It's kind of when you break it down, if you have 5 or 6 engineers on your team and you're managing 400 to 500 devices, if you decide to build two more data centers and that gives you another 200 devices, does it mean you get one more engineer to your team? Often that isn't the case. So you need to find a way to be able to manage all of these devices at scale and not have to rely on the disadvantages of the manual operation that we spoke of before. And then becomes dependency risk as well. As I mentioned in the other slide about the readability and the familiarity, is that as technical as engineers can be, really nobody can know absolutely everything. You generally find within your teams and your groups, you have SMEs or somebody who has a really good intricate knowledge in detail about that. And I've worked with many people who have a great knowledge of certain protocols or certain standards or things like RESTconf or NetConf. And they really excel in those areas. It's an area that they've spent a great deal of time of. And imagine if that person is no longer with your team, or that person is on leave or something, and you have that dependency risk as well. Having everything in a very similar format and being able to manage that entire process and that life cycle through GitOps becomes very, very important. But often businesses can only pick 2 of those things. When you go to your business and you go to your leadership, a lot of those things that they say that you can only pick, the kind of the good, the fast, and the cheap. So you have to work out a methodology to be able to do that. And this is what the team that I worked on did. This was the methodology that we spoke. We wanted to actually have all 3 of those and on the right hand side and all 3 of those on the left hand side, which we were selling to our business. So back more into that why, just to explore that just a little bit further, because it is one of the kind of common challenges that we see that businesses have is, excuse me, pushing these or getting these changes agreed with their company to make sure that everybody is on the same page. Sorry. One of the biggest things that we actually find is the wastage of skills in repetitive configuration tasks. When you're doing a lot of engineering things, you're often asked to provide a lot of granular detail. This might be about customer information, or it might be about your infrastructure itself. And speaking from experience, going through into devices, manually logging in and copying all of these things out hand by hand and then into an Excel sheet to provide into an audit, it's a very long and laborious task of doing something. And it's certainly a wastage of skill when you've got a number of people having to do this and you're dividing and conquering. It also goes into the same thing from administrators spending a lot of time doing sort of like minor changes and small configuration changes. You're pushing those changes out quite on a regular basis to update your security procedures or update customer information, which can be quite fast in an agile paced customer environment. And a lot of those changes are very, very, very repetitive. And there's a great saying that if you have to do something more than twice, you should always automate this. That's all really great. That comes down to being able to save a lot more time and be a lot more agile within the business environment. But then troubleshooting this within the face of an outage becomes monumental. I wouldn't be the first engineer to be called at 3 a.m. or 4 a.m. in the morning to look at a change which has happened earlier in the day or even early in the week. And we're going back to that camera metaphor that we spoke about right at the start, to be able to troubleshoot something that was done and it's only now being recognized and you're having to troubleshoot this. The reason for that is because without a specific way of doing any form of change control in this way, or not having that metadata to hand quite easily, you've really got no way of able to understand how any of the services were provisioned or even who did them. A lot of the time when you're logging into devices, you're logging in as admin or root. Um, Even if you're logging in with a username, you're having to go through and find who that user was. But even if you've got a username, does that make it easier to troubleshoot in the face of outage just because you know who did it? If they're sat by your side or they're reachable at that time, that might be. But if again it's 3 or 4 in the morning, then you are really faced with troubleshooting this on your own. And within a fast-paced environment, if you're making changes, you will find that those changes, you're unable to keep track of them. And so, for example, the team that I worked on were making somewhere in the region of 300 changes per month, which is quite a lot of changes. And you're having to track those changes through just change control methods and to go through tickets, which you might have in a platform like Jira, for example, or ServiceNow. And that leads to the final point of actually having no centralized reporting, that lack of accountability for all of those actions. So going into the business, you can see kind of a number of holes in this, almost like a block of Swiss cheese when you look at it. Is that these are the reasons why we need to move into this GitOps methodology and start having everything as infrastructure as code as well. So this mechanism for automation that we spoke of, and the hand-to-hand configuration of management, really, is it that scary? How much scale are we talking about? Um, from experience, I started out with networks which just had 10 devices or 20 devices, and as my career progressed and as businesses evolved, as companies got bigger and customer demand became more increased in the digital world that we live in, it becomes very difficult to do manual changes on upwards of 200 to 300 devices. And that hand-to-hand combat often leads to a lot more mistakes. The configuration management today within networking is all about the tools and the tools that you use. Those tools also should be fully interchangeable. That's one of the big things about the GitOps methodology, is that if you're running something, say, with Ansible, and you decide that you want to change into using, say, Terraform, you should be able to swap those tools out. A great example in network engineering is using things like open source libraries such as NetMiko or PowerMiko, PyAts or Napalm, for example. You might find that you want to move on to, say, something like Nornaya, or you might want to use something like Batfish, for example. And there's a lot of great network tools out there, and you want to introduce these into your environment, and you want to be able to do this very quickly and very easily. If your GitOps methodology is set up in a correct manner, you should be able to swap those tools out quite quickly, or add additional tools in that. And by using management tools and using these special tools, we are releasing us from that hand-to-hand combat and using the open source tooling frameworks which are available to us today to get that consistency and that scale as well. because built into a lot of that tooling is also a lot of checking, and is also a lot of error handling as well, which makes it a lot easier to actually build into your pipelines. And say, for instance, if you're using PyAts or PyATS, you can use this as an entire framework as your tool to actually get in there and do your also your automation and your validation in one. So really, it becomes about looking at the best sort of tools that you want to use within your environment, and we can look at a few of those tools as we get a little bit further down into those slides and which ones our team decided on using. Okay, so this is great. We've kind of got a bit of a plan now of how we want to move forward now, taking things away from hammering away on the keyboard, and probably seeing that little GIF with that cat hammering away. It's one of my favorites. But these are the tasks that we want to solve as a network team. We often found the network team became a blocker for many of the other teams, and those teams might be SRE teams, or DevOps teams, or just ops teams, or even monitoring teams within our entire business unit, or this might be even for just customers. What we want to do with by moving into this GitOps methodology was actually to simplify a lot of our operations to gain speed, agility, and efficiency. Kind of the thing that we've seen in SRE teams and DevOps for a number of years. We also wanted to deliver a lot more relevant and customized services which addressed our consumer needs. And this is, customer needs. As customers make demands, customers need you to be agile, and they need you to be able to implement features. Those features might not exist just within the network, but those features might be enabled for other teams as well. So say, for example, the customer has asked for additional monitoring set up across some of their services, which are you're hosting for them. You might have to open a bunch more access lists, or you might have to put in additional routing or a whole new bunch of policy within your infrastructure to be able to do that. And then you need to be able to do that at scale, because your customers might be might not just be in one region. Some of the networks that I've worked on have supported a fully Anycast network. So these changes have to be rolled out in many different regions, because you never know which region your customer is going to be using at the time. You have to have symmetry across all of your data centers. So these were some of the principles that our team started to work towards. Some of these principles of GitOps, and we mentioned before about taking everything away from things being in human readable format. And before this, we were storing everything in with a tool called Rancid, which is incredible for backing up network configuration devices, but it backs them up as a text file, and it backs them up just from scraping, the CLI. So what you end up doing is having to perform some kind of manual diff on two text files, and then squinting very hard after drinking a couple of espressos to be able to spot where the change is. And that's difficult enough across two devices. If you've rolled that change out to 50% of your infrastructure, it becomes very, very difficult to do that across, say 200 devices, to spot where the misconfiguration is between, say, what could be a south and a north set of data centers. So we started storing everything in a source control or version control. And in this particular use case, we decided to use GitHub. And we started to store everything in machine readable formats like YAML and JSON and XML, because this makes these formats a lot more easier to parse. It makes it a lot more easier to integrate into other systems, like monitoring systems as well. And we started to treat our source control, our GitHub, our repos, as this single source of truth. And within there, we would develop, we would test, and we would deploy everything from in our test environment into our production environment from that very, very same source. When we do this, we actually push things through into a way that when it went into GitHub, we would have a number of tools to actually do a lot of the linting for us, to check the formats like YAML and check the formats like JSON and XML to make sure that they were actually correct as they were being pushed up into the source control. Then things like errors are getting flagged, because I've spent a number of time, like many engineers, actually hunting for a space or a missing colon or something like that within a source piece of code. And so you can utilize these tools that we spoke of before to actually do a lot of that checking. Within there as well, you might have heard of the kind of the shift left strategy that's happening quite a lot now as well. And we built this into our continuous integration pieces as well. So a lot of our security checks actually got done within there. So we weren't pushing up things like SSH keys or environmental information into this source code as well. So treating that single source of truth, the source control as our single source of truth became very, very critical to our entire team. And then once we've got them in there, what do we do with them? We've spent a great deal of time of creating these great templates in the machine readable format and having a lot of our sort of inventory written in the format of in YAML. How do we deploy that? Because we wanted to limit that configuration change as well. And we can actually have our source control do this within an entire pipeline for us as well. So we don't even have to push this out manually. Once our checks have been gone through their validation, and once this source code has been taken from a branch and pushed into the main branch, ready for testing or to put into the production environment, we can limit how much interaction that we actually have with this. So again, we're not trying to go through the code and actually kind of spot the mistake. What we're looking at is for things like tests which have passed and validation that this is made and that this is a change which we are happy to actually make into our production network. And this is where we started to really explore configuration management tooling in that place of that kind of shift left strategy for network automation of how the continuous integration started to actually work for us. And so on the right-hand side, what you can see is just kind of something that I took from a whiteboard, which I drew many years ago, of how I wanted this actual flow to actually take place. So we kind of start off once the change has been pushed into what we consider into a post check. And the post check is that linting piece that I spoke of, where it's being checked to make sure that it's actually valid. The pre-check would actually be the human into part now, where one of my colleagues would actually look at the branch, for example, and then actually begin to merge this into the production. Once it was merged into the main branch, this would then be fully executed. CI/CD tools would then kick in once that merge had taken place to actually start executing that code. And it would go into a verify state, which was in a test environment. If anything was then seen within the test environment, that change would be rolled back. And the rollback piece became very, very critical for our team as well. Beginning of the days of when we started doing automation, we could automate sort of northbound out to all of the devices. But then when it came to rolling back, it became difficult to actually roll back those changes. And that comes from the manual intervention of the CLI, which I meant a lot of the time in our early days of automation, pushing device or changes out via automation. If something did go wrong or we wasn't happy with that change, or we saw that trickle effect of an outage beginning to happen, the rollback would then have a sort of a human element as well of having to go in and undo a lot of those commands. So building that rollback into all of that pipeline then becomes equally as critical. Often I found, especially when dealing with customers, is that customers understand that there will be outages. And you spoke about some of the big companies like Amazon and Facebook, who themselves have outages. Outages happen. Mistakes do get made. And customers will understand that. Businesses will understand that. But the ability to be able to roll back and undo those changes becomes very, very critical. And how quickly you can actually get back, your services and make them work again. So super duper, we've built this really nice pipeline. We've embraced this GitOps methodology. We've got everything moving into a source control. Everything's being validated and checked. We've moved all of our stuff into machine readable files, and this is now in the production network. What does this give us? What kind of information, what kind of telemetry and metadata are we able to get from also having this installed on here? It's often very painful for other teams and other people within businesses to be able to request information. I mentioned a little bit about being the blocker for a lot of teams, and this comes down from also getting information to making changes. A lot of the time within infrastructure, you're asked to provide information for things like security breaches when risk assessment is put out. And a lot of teams kind of work in a traffic light environment when it comes to security and risk, where the kind of the green state is, well, we need to fix this, but we can do this down the line. We're not at immediate risk. The amber is, we need to start investigating this now. And then red becomes, we need to start patching this yesterday. A lot of the time within network infrastructure, you are updating and upgrading software on a regular basis. And this is for, things like features and also security patching as well. And also to make sure that you're unified across, and all of your devices are often running the same code train. You need to be able to perform audits quite quickly on a lot of your devices, and it's really, really cool to be able to request that information in real time with using your sort of like telemetry pipelines, and to be able to get that information back. One such situation, where I'm upgrading around 200 to 300 firewalls, it takes a very long time to do. We're working through this with automation as it's doing this gradually across our entire global estate. And we're doing this kind of region by region, and you want to know where you are within that particular process. I kind of liken this to painting a large bridge, like the Golden Gate Bridge, or if you're in England, the Humber Bridge. And when you're painting this bridge, by the time you get to one end, you're often right back at the start doing this again. But you need to know where you are within the steps of the way, because it wouldn't be the first time that you've gone through updating, to patch something, and then once you've updated to that patch, you've seen that it's had potential impact on TX or RX traffic going through devices, because there's perhaps a bug within that code train which limits certain types of TCP traffic or flows, and you have to roll back. So it comes down to a state of being able to understand where you are within this, both from a upgrade status and what version is installed. The other piece of the characteristics that you want to know in the desired state is the attributes of who owns things. There was that piece when I was talking about troubleshooting in the face of outage, is you might be called during the day or the evening time, and you're seeing high spikes of traffic across an infrastructure, a port channel, or network devices reaching high point of CPU, or even another team is seeing infrastructure go out to their cloud. Services are being used, or a customer might be seeing high utilization of services. You want to be able to identify who actually owns this. That metadata, which is stored in our source control, is able to help identify this and who owns those particular services, or where those services were made, because within that sort of framework that you're pushing, you're able to identify and comment and tag what those services are there for, and you're able to put in things like RFC numbers or change control numbers, or even customer ID numbers, to be able to identify what particular service that traffic has been enabled for. And this goes down into the final point of the feature-specific configurations, where I was mentioning before that customers want a particular service, and one thing particularly comes to mind where we was asked to deploy a certain service for a customer, but this service was very, very unique, and this was the way that their firewalls handled TCP traffic. So we had to start making some kind of exceptions and change window sizing within our infrastructure to be able to handle the large TCP window sizing for the customer, and that had an effect where we had to put specific configurations these specific configurations tend to really stand out. They tend to jump out like like a snowflake within your environment, and you want to know why they're there. Having again that metadata to be able to point to that and to be able to understand that, so that configuration isn't removed. So there's three stages to this. This is the as is state, the desired state, and the kind of the benchmark state. And so when you're working with your device, you're looking at your hardware out there, and this goes into that kind of the pre-check environment where you're taking the pre-test device, where your automation and your pipeline is actually looking at the device and it's saying, what state is this device in? This is going to be the state that I'm pushing this to. Does this meet the benchmark state or the standard that we've actually defined to have across all of our devices? And if this doesn't meet this desired state, then this change within the pipeline would be or could be fully rejected, or could be pushed back for further analysis, or could be flagged for inconsistencies across, the some of the infrastructure, or possibly all of this. So what did the end game actually look like? We moved a lot of that configuration into code, which enabled our network administrators to treat all of our information very much like software code. It enabled us to help moving configurations to get developed and deployed with a lot more of a modern technique, instead of just copy and pasting things into text files. Now we're able to also review these, and instead of having to eyeball changes again in text files or within a ticketing system, we can see this in the version control system. And within modern version control, you can see the pluses and the minus within GitHub, showing the change which is actually going to be able to be made. We can also perform now automated testing on all of this. Again, it isn't based on somebody's experience looking to say, yes, that will work, or or no, that won't work, or even perhaps we won't even see until it goes into production. We're able to also simulate testing, and we're also able to push that through as a peer review in that process as well. We're not totally removing the human element, because we still want to be engaged in all of the changes that we want to make across our infrastructure, but we want to remove some of that continuous scrutiny of human element and wasting time and resources, when engineers could be spending more time developing and bringing up new services and new techniques and tooling. We also wanted to build this self-serving monitoring system, which we did, where the network automation is continually self-monitoring all of our pre-selected key performance indicators, or KPIs, in relation to the network, and notifies any breach of change. Sometimes you will find that in the case of an emergency, the system, the processes that you have in place, sometimes things do get circumvented. This often happens at 3 or 4 in the morning, when an emergency change is wanting to be made across the system, and a kind of a little emergency hack is actually placed into a system, and that becomes that one kind of snowflake. If an engineer makes those kind of changes at 3 in the morning and then doesn't revert those changes at all, once that network automation or that self-monitoring picks up, it will alert people to those changes. And back in the day, that really didn't happen. And that became again a very sort of humanized manual process, spotting where changes had been made outside of the system, or outside of a change control, or one that didn't align to this. So a lot of the time, this really doesn't apply to, say, somebody hacking into one of your devices. A lot of the time, these changes come within the network infrastructure, or have been made by mistake, by random scripts being ran and deploying these snowflake configurations. Adding all of these things together in an end game for us gave us this great case for event-based management, to allow us to correlate current events with similar events. A lot of the changes that you can sort of see happening, we spoke about the metadata there, within the source control, enables you to identify changes on a recurring pattern. This becomes that predictability that we wanted, and I liken that to kind of like a weather map, which I spoke of before, and how we can see the impact of, say, heavy rainfall, and how it would in fact impact a local drainage service, to how heavy traffic might in fact impact a network infrastructure base, and changes that were made. So it gives us that a lot more agile ability to be able to revert those changes a lot quicker, and be able to jump into those things and correlate them with similar events, such as global traffic changes and global traffic routing, and also automation changes that have been made across all of our infrastructure. So I said I'll just show you quickly how we actually did all of this and what that entire process would look like, and some of the tooling that we used. One of the questions you often get asked is are these the tools that you would recommend? And I always say, well, tooling is very, very prescriptive, and for one company or one person or one particular team, certain tools are good for you. And I would always encourage anybody going on this journey or in this journey to analyze and look at the tools that you're using, whether these are open source tools or whether these are commercial tools. Sometimes you might start with open source tools and then you might go into commercial tools, or sometimes you might just swap out one open source tool for another, or you might be really adventurous and begin to build your own, such in the case of, where you're building things like parsers or something, or you're looking for additional support in certain vendors, which you can't get through open source or you can't get through commercial tooling. So what did this pipeline look like? Well, the pipeline included policy, automation, the pipelines itself, the telemetry and assurance. I want to capture all of those things which came within this entire sort of GitOps lifecycle. And so what happens is we've got Carl, our engineer on the left-hand side, makes a code change. And then Carl tests this locally using a network simulator. And the network simulator, there's a number of those around. For network automation, we tended to use Firewall or CML, which is a modeling lab, which is able to do this. What we then do is we then commit this into our pipeline, and it begins this build. It begins the actual build of all of the code and structures this together. And to do this, to start with, we used Jenkins to be able to do this. We were able to add the Jenkins plugin into our GitHub to do and help with a lot of our CI/CD pipelines and our validation. In the step 5 here, this is where our test network would often get built. The test network can be spun up with a number of tools such as Terraform and Ansible and Python. And we were building this using a platform called NSO, which acts as our software-defined network controller within all of our environment within CML, which would help us define all of our baselines and all of our templates, which would build all of these things together. The entire CML was actually brought up by a playbook in able to do this. So the topology or all of the network devices with all of the services are actually then fully built in to get a like-for-like infrastructure copy of what we had within our production. If everything passes within there, we actually apply our code changes. And this is why we start to apply our test plan. This is where it goes through the stage where I spoke about using PyAts and Genie to actually do that full status reporting and pull out any information. All of that information will be then reported to us in. Didn't have to rely on emails being sent to us. We would get these through various different points of sort of chatbots, building various chatbots through WebEx, Teams, and Slack to be able to produce and give us information in a real time for when that change is actually going through the stages and what it looks like when it's in that stages, such as the provisioning and the build and all of these things. So we're not having to constantly monitor things going green within a UI or something, or looking at code being completed within a terminal screen. Once everything comes back green and we've seen everything's happy, the test plan is good, this then gets deployed into our main branch and would be pushed into our production environment. So this is what our entire sort of DevOps CI/CD pipeline looked like from beginning to end, essentially. So this brings us to the end of the session of my presentation today. If you've got any questions, please feel free to reach out to me. And all my details are on the left-hand side. I don't often sit in a boat, but it is how often I like to spend some spare time and do a lot of thinking these days. You can reach me at my Cisco email address. I'm very active on Twitter. a lot of the code that I've talked about today, or the methodologies around network automation, you can find on my GitHub repo, which is Big Evil Beard. And you can also find a great deal more examples for this over at Cisco DevNet, where we have some sandboxes, learning labs, and a whole bunch of code for you to go through to help you on a coding journey if you're just getting started, or to inspire you to try more coding or new methodologies through all of those things. All of the content on developer.cisco is completely free. So you can just hop in and try this as much as you like, and just have fun and play around with it. I'm going to be sticking around for 5 or 10 minutes now just to answer any questions. So I'm going to hop now into the Q&A. Thank you for joining this session today. And if you've got any questions, I'll see you in the Q&A now.
Thank you very much, Stuart. Great presentation. Love to see it.
Thank you.
Love the perspective you take in it. I'm looking to the Q&A box. Currently, I just see one more like a comment that Augustus would love to hear and see some more practical use cases, pros and cons of GitOps approaches. Pretty sure your Twitter, your repo was full of it.
Yeah, some of the pros and cons, I think, is adaptability, within a networking infrastructure, certainly. A lot of teams like, DevOps and SRE teams have been doing this for a great number of years, but some of the the cons of this is actually building some of this framework. It does take a great deal of time to actually do this. This isn't something that is done overnight. So we started with things like low-hanging fruit, the sort of repeatable changes and things to start with that, and the things like what we would see as get requests, things like which are idempotent, where you're not actually making any changes to your infrastructure, just retrieving information as the first step. Some of the the other cons as well is that in the beginning time, this didn't go right for me or the team that I was working on. Automation is fantastic, but instead of that manual way that we spoke of doing things wrong on one device, with automation, you're kind of doing this wrong on many devices at once. So it's the con of this is you can cause outages a lot quicker, and it became kind of someone said to me, you don't want to be the person delivering the good news and the bad news, where the bad news is I've caused an outage, but the good news is I did it with automation. You don't want to be in that kind of that kind of space. Some of the cons we did speak of in some of the demo is having that telemetry and that metadata, having everything automatically there, and being able to reference this as that single source of truth became very, very critical for our team. Of pushing that in there and having everything in machine readable format made it a lot more easier to also integrate other tools within there. As we more adapted to this and became more confident in there, we were looking at integrating a lot more tools in there, and it made it a lot more easier just to keep layering on and building tools within there from that manual thing.
Thank you.
There we go. Great question. Thank you.
One last minute, because also we have to jump over to the next talk. What tools are you using for testing, and especially integration tests, for network changes?
That's a great question. Thank you for asking that. So one of my favorite tools is PyAts, or PyATS. So PyATS is a great integration tool for actually doing this. It's a complete test suite framework which can run with both Ansible and Python, and is basically able to do all of this for you. And that is one of my favorite tools to be able to do in network testing and validation as well. Yeah, thank you. Great question.
Perfect. Then thank you very much again, Stuart. I have to shut down this session. You can stick around. You can find the people on Slack. And I wish you all a very great day, and especially the rest of the week. See ya.
Thank you, everybody. Have a great day.